This is a quick review of all of Unit 4. In this video, I'm going to go back to basics and discuss negative and zero exponents, representation of the nth root of a number, how these are related to irrational numbers, how to use your calculator to find a root, and then use flower power to help you remember. Refer to your Unit 4 rubric. We're going to focus in this next little bit on what these two rules mean. In our order of operations, also known as bird mass, we're at the exponent and root part of the order of operations. Let's work with the powers of 2. 2 cubed, by definition, is 2 times 2 times 2, and we can evaluate that as 8. 2 squared is 2 times 2, which is 4. Watch what happens as we continue our pattern. Each time we are dividing the number above by 2. Each time our exponents drop by 1. By the time we get down to 2 to the 0 power, we get that 2 to the 0 power equals 1. Let's continue dividing out from above by 2 and dropping our exponent by 1. By the time we get to 2 to the negative 1, we see that it is equal to 1/2. 2 to the negative 2 is 1/4 as we divide both the 1/2 by 2. If we divide the 1/4 by 2, we get 1/8. Don't forget the 8 is 2 times 2 times 2, and it turns out that 2 to the negative 3 power is 1 over 2 cubed. We can generalize now. X to the negative n power is 1 over x to the n. Let's back up to this 2 to the 0 power equaling 1. It means that there are no powers of 2, but you multiply by 1. So x to the 0 power, of course, is 1. We cannot have x equal to 0 because, remember, we were dividing by 2 each time and we're not allowed to divide by 0. Same goes with our formula x to the negative n equals 1 over x to the n. X cannot be 0. Let's explain now why a to the 1 over n is the nth root of a. We have do and undo operations. For instance, 2 take away 5 is negative 3, because negative 3 plus 5 is 2. 6 divided by 2 is 3, because 3 times 2 is equal to 6. The cube root of 8 is equal to 2, because 2 times 2 times 2 is equal to 8. When we have 8 factored into its powers of 2, we see that to get the cube root, we only want one of the 3 powers. So we want to share that powers for the cube root, and we want to share those powers over the 3 spots, or we divide by 3. Or in other words, dividing by the 3 is multiplying by 1/3. And that is why the cube root of x is x to the 1/3. Generalizing now, the nth root of x is equal to x to the 1 over n power. Let's see how prime factors are related to the nth root of a number, and then see how these roots will give us irrational numbers. Let's look at the cube root of 16. I know that 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. 8, 27, or 64 are perfect cubes, and 16 is in between the 8 and 27. So I'm expecting the cube root of 16 to be in between 2 and 3, and I'm just going to guess 2.4. Let's do it by prime factorizing 16. 16 is 2 times 2 times 2 times 2. There are 3 spots to fill in order to find the cube root of 16. I can share 3 of the 2's into each of the spots, but then the last 2 I need to split up, and to make it equal, I'm going to call it the cube root of 2, and I'm going to put the cube root of 2 into each of the 3 spots. Therefore, the cube root of 16 is 2 times the cube root of 2. The cube root of 16 is irrational. Irrational means not rational, or not a ratio, or in other words, not a fraction. The cube root of 16 cannot be written as a over b, where a and b are integers. B cannot be 0. This is the formal definition of a rational number. Let's see what this means. 6 over 5 is a rational number. It divides out as 1.2. It is a terminating decimal, or a repeating 0 decimal. 2 over 3 is a repeating decimal. It is 0.6 repeating. However, if I find the cube root of 16 using my calculator, I find that it is 2.9 9, 1, 9, 8, and a bunch of digits afterwards. This will not repeat. So the cube root of 16 is a non-repeating decimal, and the cube root of 16 is irrational. Irrational numbers, though, even though they don't repeat, can still have a pattern. Here are two examples of irrational numbers that have a pattern but do not repeat. Next, we're going to use flower power to help us express a power with rational exponents. First of all, here's an example of 25 to the 3/2 power. I'm drawing a flower here, and the flower is above the ground, and underneath the ground are the roots. The flower is the power, and the root is the root. So for 25 raised to the 3/2 power, the 2 is the index, or in this case, the square root of 25. The 3 is the power, and we raise the 25 to the 3rd power. We can simplify this by first finding the square root. We can find the square root of 25 first, and then raise it to the 3rd power. The square root of 25 is 5, and when we raise it to the 3rd power, it is 5 times 5 times 5, or 125. Let's look at our rubric now. We've covered everything except these two here. This pretty much covers everything in the Unit 4, except for the extra practice that you might need to solve problems that involve exponents and radicals. But basically, all the items in this video have been covered, and we just need to practice. See you in class.